Hi there. In this video, we are going to be solving this system of equations, and we're going to make use of this workflow to help us through the process. The first thing that I'm going to do is identify one of these equations as equation 1. I'm actually going to choose the second equation and give it the label EQN1. And the reason is it's going to be the easiest equation to solve for the variable x in this particular case. Now, once I have equation 1 and solve it for x, I'm going to take that expression and substitute it into equation 2. Now we only have one equation left, so I'm just going to give that first equation the label EQN2. Now, let's just review what we have. We have equation 1 that we're going to work with first. We're going to take that equation, we're going to solve it for x, and then we're going to take that expression, substitute it into equation 2, where we're going to actually get a value for y. And then we're going to substitute that y value back into equation 1, which will enable us to get a value for x. So we're actually going to be able to evaluate a value of x there. So the last step here is going to be back to equation 1. All right, let's get started. Let's break this up into 3 steps. So we have step 1 dealing with equation 1, step 2 dealing with equation 2, and step 3 back dealing with equation 1. So now we can get started with equation 1. And I'm going to write this in blue to match the label of EQN1. So we have x minus 4y is equal to 36. Let's go ahead and use some definition of subtraction, giving us x plus negative 4y is equal to 36. Now we're going to solve this equation for x by adding 4y to each expression, leaving us with x equal to 4y plus 36. All that we have done here is change the form of the equation. It's the same equation, it just looks differently. In fact, I'm going to put a star there to indicate that it's still equation 1, but it just looks different. So we now have taken equation 1, expressed it in a different form where I have x equal to some expression of y, so that I can take this value of x and substitute it into equation 2. So let's go ahead and write out equation 2. This time I'm using red. So 2x plus 5y is equal to 7. And now I'm going to replace that variable of x with the expression 4y plus 36. And that is coming from equation 1. And then, of course, not to forget the remainder of the expression. So plus 5y is equal to 7. Now we're going to need to go ahead and expand here. So we get 8y plus 36 times 2 will give us a product of 72 plus 5y is equal to 7. Using some commutative law of addition here to add those like terms, we are going to end up with 8y plus 5y plus 72 is equal to 7. So we're throwing in a couple extra steps here. Now we're just going to go ahead and add those like terms. 8y plus 5y gives me a sum of 13y plus 72 is equal to 7. We are now in the process of solving this equation for the unknown variable y. Adding negative 72 to both sides, we get 13y equal to negative 65. And now we can go ahead and divide each expression by 13, giving us the equation y equals negative 5. So this is still equation 2. It just looks different, except now I know the value of y, for which I can now substitute back into equation 1. And that's going to allow me to get a value of x. So which equation 1 equation am I going to use? I'm going to use the one that is already of the form x equal to some value, because I'm trying to find the value of x. So let's go ahead and write that equation. X is equal to 4y plus 36. Now I can go ahead and substitute that value of y, which is negative 5. That is coming from equation 2. And not to forget that last term there of 36. We're going to go ahead and evaluate the value of x here. So we get 4 times negative 5, which is negative 20, plus 36. Adding those two terms together, we get a value of x, which is 16. So we now have the solution set for this system of equations, when the x value is 16 and the y value is -5, both these equations will be true at the same time. They will be true simultaneously. So I'm now going to show you how you can check your result using GeoGebra. Now I am using the exam.net version of GeoGebra and my language settings are switched to Swedish. Step 1 is to enter one of the equations, and notice that GeoGebra will automatically label this object as EKV1. And I'm just going to go ahead and change the color of this to red to match our EQN2. So this is really our second equation. I'm going to also increase the line thickness a little bit so it's a little easier to see on the display. Next, we're going to enter our second equation, and GeoGebra will give that object the label EKV2. And again, I'm just going to change the color of this to match our algebraic solution. So we're going to change the color of our EQN1 to blue and change the line thickness as well. Now in standard GeoGebra, all you need to do is find that point of intersection of the two lines, click, and it will give you the ordered pair that satisfies both those equations simultaneously. But since we're in ExamNet, we need to provide the intersect function that has two arguments or inputs, which are the equation labels EKV1 and EKV2, and that will return the ordered pair that solves our system of equations. My name is Mark. Thanks for watching.